Hi everyone and welcome to Ombarus, the complete roguelike tutorial in Python using libc code part 8 and 9. Last week we added fighting and a basic HUD to display the player's health and a few log messages, and this week we'll be adding scrolls and potions and an inventory system to go with our dungeon generation. If you're new to this series, I've been following this RoguelikeDev tutorial from the RoguelikeDev subreddit along with everyone else who's following along in the last couple of weeks. And if you want to post your progress or anything, you can go on the subreddit and everyone is very welcoming and will help you with any questions you might have. Or you can also leave a comment below this video and I'll be happy to do my best to help you. Also, up till now, we've been setting things up, and I think it's been pretty easy to show everything and every mistake I make along the way as I follow the tutorial, but slowly, surely, every part is starting to take longer and longer as we add more complexity, and now I have more than 2 hours of recording of the part 8 and 9 stuff, and I don't know that anyone would want to watch me program for 2 hours, so I might try this week to cut some parts a little bit shorter, but I'll still try to show you the complete code. But in case I missed something, you can always go to the GitHub page that I've linked below this video and check the source and make sure that you aren't missing anything. Don't forget to also check the masterfully written documentation on rogueliketutorials.com that will be linked also in the description below. Like I just said, our game is slowly getting more and more complex, and as we're adding more complexity, it's a good idea to start thinking about what we're trying to do and try to describe it from our little game's point of view. For example, obviously, new items will have to be some kind of entities because everything we place on the map is entities. And the only way to make these entities behave differently than the monsters we have in our game right now is to change their composition using components that we've created in the last few weeks. And the main thing we have to work on right now is figuring out a way to make these entities pickable by the player and also put them into some kind of inventory. And once we have that, then the thing we're going to have to do is figure out a way to update our UI so that we can display this inventory and potentially use the item or drop it again if we don't want it in our inventory. So that means that the first step is going to be generating these new pickable entities. So let's start with just adding random potions in our game. And to do this, we're going to go back into the place entities method in our game map and just add new drops into our level. And when we added this method a few weeks ago, I did say that we were going to come back to it often, again and again and again, because every time we want to add a new item, that's probably the first place we're going to go for it. Now, these new potions we're adding, they need to be picked up by the player and stored in some sort of inventory. So we need a way to tell our game that the player can pick up items and that certain items can be picked up because it's not all items that should be able to be picked up, right? So if you've been following what we've been doing up till now, you'll realize that this should be easily done by adding a few new components. For the player, we'll give him an inventory component, and this component will not only keep information about the inventory size and the list of items that we have in our inventory, but we'll also be able to add methods to manipulate the inventory and do a couple of checks for like inventory size or how to use items or what kind of items or how it's divided in the inventory and whatever else we decide to add to our game. Then, since not everything should be picked up, well, we need to create an item component that will tell our game that a certain entity can be picked up and put inside the inventory. For now, this component just needs to exist to tell the game that this item is pickable, and it might seem a little bit overkill to have an empty component just as a form of boolean to tell the game that a certain item is pickable, but as we add more rules and logic, we'll revisit this item to add some code inside of it to use the item and to keep properties about each of those items. So don't worry about it. This class is going to be revisited soon. While we're adding all this stuff, one thing that's starting to bug me with the tutorial is the way we always end up passing so many variables as parameters to each of the methods we want to call. Look at how we initialize our entities now. We just have this long list of properties and parameters, and I feel it's a little bit tedious every time we want to add something to our methods that we have to change its signature and then go back in the code everywhere we're calling this method and update the signature everywhere. And if we don't want to do that, then we have to figure out a way to pass it some default values all the time. And I feel that this is probably not the best way to do it. We could definitely use some kind of dictionary of configuration or something. And the interesting part with that is that if we had the dictionary, well, we could eventually just store it as a JSON or something, which would allow us to be much more data-driven without having to modify the Python script every time we want to add a new component or something. But for now, it's still relatively simple, but I'm sure eventually as we add more and more components, we're going to eventually have to find a way to simplify the method signature a little bit. But anyway, now that we've set the groundwork for knowing who can pick and who can be picked, it's time to go back to our old input_handlers.py and add a few new shortcuts. Because if we want to be able to pick up items, then we have to add the traditional keys for picking up stuff in roguelikes, which is G for grab and D for drop. Again, we're not directly going to process the key in input handlers, but instead we're going to return a command that will be processed by engine.py and our new components that we just added. As a side note, I tried getting used to the Vim key layout to move the character around, but I was finding it a little bit awkward. I'm just not used to using Vim, I guess. So I took the opportunity while I was playing in input_handlers.py to just quickly add the numpad keys as an alternative way of movement for the character. I didn't remove the Vim commands or the arrows, I just added some new possibilities to make my life easier. To add items to the inventory, we need to validate that we're not going over the capacity and one day potentially over the weight of the character. So instead of accessing the array in the inventory component directly, we're going to create an addItem method and run our validation in there and return the results as an array, just like we've done for all the fighting stuff. I probably don't have to explain all of this in very much detail, because if you've been following the previous tutorials about the fighting and all that, you're going to see that we're kind of following a pattern here. As usual, as soon as I think I can test that nothing is broken, I'm going to run the game quickly just to make sure that everything is working. As usual, I made a bunch of typos and stupid mistakes, and it took me a little bit of time to correct all of this. But once I had everything figured out, I could test the game and make sure that the new shortcuts are working and that the buttons are working and that we can still move around like we used to. So now that I know that I'm not crashing when I try to pick up an item, it's time to actually remove this item from the ground. And to do this, all we need to do is just remove it from the render list that is our entity array in engine.py. Of course, we could modify the array directly in the inventory component, but since we're probably going to be modifying often this array to decide what we want to render or not, it's probably a good idea to keep it centralized in engine.py, and that's why we're going to instead return the command from addItem to tell engine.py to modify the array of entity. Now it's time to start thinking about how we're going to display the inventory. And we're going to try to make it somewhat generic, since displaying a list of options with a question is probably going to be one of the most common things we'll have to show the player. Whether it's a list of spells to cast, or a list of what you want to drop or want to pick up, or maybe a list of dialogue options, it's all going to have pretty much the same format, and they should all be displayed with kind of the same basic idea. So we'll make a new script, menus.py, and we'll add the menu method that will take as a parameter a header that will be the question we want to ask from our menu, and a list of options that we want to display, and this menu method will assign a letter to each of those options, which gives us the possibility to add 26 options, and the player will just need to hit one of these letters and it will return the option associated with this key. Now, the rest of this menu is nothing we've never seen before. We're just using some of libdcode methods to render it inside the console, and then we are going to blit this new menu inside the render buffer and somehow call it in our render function when we want to display the inventory. Now, something that people often struggle with when making a game is handling all the different states the game can be in. And 2 episodes ago, we added this simple game state in engine.py with 2 possibilities, player turn and enemy turn. And we made the game behave differently depending on which state we're currently in. Then the last episode, we added another state that was player death, which freezes everything when the player's HP reaches 0. Now this week, we'll have to deal with a few different events that needs to be handled completely differently from the normal flow. For example, when the inventory is open, we don't want the player to be able to move or act like he normally does. We want the player to be navigating the inventory menu. And if you've understood how we use states up until now, then you'll see that the inventory is just a different state of the game. By doing it like this, we can easily test at various places in the code if we're in a state where this part of the code should be evaluated. And this way we can change the behavior of the game depending on which state we're in. As you can see, there's a lot of back and forth every time we want to add a new action. I have to go into the game state enum and add a new state. Then I have to go into handle inputs.py and add the new key presses and shortcuts and give them an action. And then in engine.py, I have to add new code to handle this action, and then this action is probably going to call some new methods that I have to implement. For example, calling our new menu methods from the render functions, and then checking the states. Only when the show inventory state is there, I can display this inventory. This is fine for the size of the project we have right now, but in a bigger project where I would expect to have hundreds of different states, having to add all these little pieces of code every time I add a new state is, I feel, a lot of work. So I haven't thought about it very much, but probably if I had to add a lot more states, I would probably try to find a generic way of handling a state change, maybe with some classes, like instead of having the enum just be a variable that I can check and add ifs everywhere in my code, maybe I would have a complete class that just does everything differently. Or maybe I would have function pointers so that directly assigning a new action would call a new method without having to modify engine.py. I'm not sure exactly how I would do it, but I would probably start thinking about how to make this a little bit more easy whenever I want to add a new state. But for now, it's totally fine to do it like that, but it's something to keep in mind. Now that we can go into our show inventory state and display the inventory, we can create a separate input handling methods in our input handler script for each game state. This way, there's no chance when we're in a show inventory state that we're going to trigger by mistake, for example, the keys to move the player around. Our new handle inventory keys method will only process 2 actions: closing the inventory with the cancel button and returning an index based on the alphabet letter that was pressed. So A would be 0 and Z would be 25. Assuming that the items in the inventory are in the same order as when we displayed the list in the array, then it means that this index is a direct reference to our item in our item list, and it should be very easy to access. Now that we know which item the player wants to use, we need to execute some kind of method to apply this object's ability in the world. And I think there's quite a few different ways we could do this, But in the tutorial, what they're doing is add a new property to the item component. And this property is something we call a function pointer, and we add to it a list of arguments. This function pointer is a little bit different than a normal property because instead of pointing to a specific data like a float or an int, it's pointing to a piece of code. And the reason we're using this is that instead of having to have like a lot of complexity or switch case or separate components for each different type of item, we can just create a new method and set this function pointer to our new method. And this way, the same component can be used for all sorts of effects. And it's a really neat way of giving a different set of abilities without having to do too much coding or having to add too much complexity to our code. Still, to actually execute this effect, we're going to need to add a method somewhere. So to do this, we're going to create a new script to hold all the items effect that we can have in our game. And we'll start by implementing the heal method for our new potion. If you're wondering, the star and double star in front of our function parameters are a form of magic variables in Python. Their words, not mine. This allows us to define methods with a variable list of parameters. As you can see, the first thing we do when we write the heal function is to unpack these arguments of the method into separate variables. In this case, args with a single star is an array, and kwargs with 2 stars is a dictionaries of parameter, which means that when you're passing args, you need to pass them in the right order and you access them by a certain index, where with kwargs, you must give them a name and you pass them in any order you want. Now this heal method we are adding is going to be responsible for triggering the effect and deciding what to do with the potion. It doesn't really know about how to restore health. For this we need a new method in our fighter component that we'll also call heal, that will be responsible for doing the actual healing of the HP of the character. So you shouldn't confuse those two methods. And now we need to link the function in our item functions with the new properties we created in the item component. And to do this, we're going to go back into the game maps place entity method and link our function with the function pointer property in the item component. And we're going to have to pass it some new initialization parameter to tell it how much heal the potion is going to give you. We also need to add a use method in our inventory component that will be able to call the function pointer of the item we want to use and do some validation to make sure that everything is properly handled, and also remove this item from the inventory if the use method was successful. Along the way, we keep a habit of adding a list of results and messages and action to an array and return it to the engine.py to be processed at the end. So if the potion was in fact consumed, we'll assume the player has finished its turn and update the game state to let the enemy take its turn. And picking up and using inventory is fun, but we also want to be able to drop them. So let's add a new drop inventory state and trigger this state in input handlers. Just like we triggered the state of grabbing items, we're going to have to add a new shortcut to drop items. And this is going to be very similar to the way we use item in the code, but instead of calling the function pointer and calling use in the inventory component, we're going to add a new method in the inventory component to drop an item. And what this is going to do is just simply re-add this object in the render list and remove it from the inventory component. And of course, we need to go in our render function and make sure that the inventory is going to be displayed not just when we're in the use inventory state, but also in the drop inventory state, and update the header to display just a different message based on whether or not we're in the drop or use inventory state. But aside from that, the whole flow is basically going to be the same thing as when we want to pick up and use an item. And now that we have this, we can test that everything is working. We can move around the dungeon, pick up a potion, drop it, or use it, and see that we're actually regaining health when we use it. And with this, the dungeon has become a lot more fun, and our survivability has increased quite a bit. But adding a single item is not going to really be a challenge for our now powerful engine, we need to make sure that we can add any type of item we want. And to really make sure we can create all the most amazing items in the world, we need to add a few more that will test the limit of the current system we have. And that's why in part 9, we'll add some spell scrolls and start casting some ranged spells. So the first thing we're going to do in part 9 is start with a basic lightning spell that will simply target the closest enemy and deal a fixed amount of damage. We go into our item function script and we add this new code to trigger the lightning, just like we did with the heal spell, but this time instead of applying it to ourselves, we'll pass the list of all entities and look for the closest valid target and apply the damage to this target. What's nice with the way we've set up everything in the previous part for the heal potion is that now that we have the method for casting the lightning, the only thing we have to add to actually put it in our game is something in place entities to generate it in our dungeon. Everything else, removing it from the ground when picked up, calling the function pointer when we use it, or adding it to our inventory, it's all already generic and handled by the same code that handles the potion. The only thing we need to modify for the cast lightning to work is to add the list of entity as a parameter to the KW args when we call the use method, so that we have the list of entities in our cast lightning method so that we can find our target. And with just this, we can already test that everything is working, that we can pick up our scroll, that we can use it, and that it's going to blow up the closest enemy. But let's be honest, it's kind of boring to cast spell without being able to choose your target. So let's go to the next level. We don't need to change what we already have. We're just going to add a new spell, but this time we're going to add it with an area of effect and the ability to select the origin. So let's add the famous fireball. Now doing the targeting is going to be a little bit tricky. So to figure out what we need exactly, we're going to start by adding the cast fireball method to our item functions. Coding the behavior of the fireball, we see that we need the list of all entities just like we did in cast lightning spell, but we're missing some origin. The target X and target Y that we calculated automatically in cast lightning, now we need to somehow pass it to our cast fireball method. Now to get our target, we need to go into some sort of targeting state. And once again, this is going to change the behavior of our input. We could do the targeting with the keyboard, but in the previous episode, we already added mouse control, so let's just go with that. It's going to be a bit easier for now. When we're in targeting mode, the handle keys method will basically be empty, and we'll add a method to get the mouse clicks instead. Now, we also need to set up the engine.py to be able to go from player turn to show inventory, then to targeting, and then use the item and switch back to the enemy turn. I really like how the tutorial handles this, because even though I'm following someone else's tutorial, this is pretty much exactly how I would have done it, including suspicious stuff like using target X and target Y as a hackish way to let the inventory component know if it should consume the item or tell engine.py to switch to targeting mode. Basically, we added properties in the item component to tell the game that a certain item needs targeting. And if it needs a target, then the engine tells the inventory to use a specific item, and then since there's no target attached to it, the inventory will first tell the engine to go into targeting state before re-triggering the use method with the new target parameters. So here's the sequence of how everything goes down. We've added a new targeting state, and in engine.py, when we're in that state, we check the handle mouse return values to figure out what's the X and Y of our mouse and if we've done a right click or a left click. If we've done a left click, then we use our inventory component's use function to set the target X and target Y, and we can basically cast our spell just like we did everything else up till now. The last step we need to do is add an item that will use this new system. So we go back into place entities and we had yet again another fireball scroll to our game map, like we did with all the other objects up till now. Now there's one last thing we can do to make sure that our system is really powerful and can do pretty much anything we want. Because up until now, the only thing we've been doing with our spells is deal damage or heal damage. What about some more complex behavior? Let's do a confusion spell that will change the AI of the enemies for a certain number of turns. If you've watched the previous videos in the series, you know that the brain of our enemies is the basic monster component in AI.py. So to make a confused monster, we'll just create a new confused monster component, and this component will replace whatever was there before. So we need to remember the previous AI, because it could be something else than basic monster. For example, the player could be turned into a confused AI for a few turns, then return to the non-component to give back the control to the player. Next, just like we did with all the other items before, we're going to go into our item functions.py and add a new castConfuse method that will trigger the confuse behavior, which will only switch the AI component of the entity, and everything else will be automatically handled by the confuse monster component. And that's really all there is to it. Just add a new type of scroll in the game map to generate the scroll of confusion, and we're done. As you can see, everything we added before helped us create a generic system that can support new content with minimal additions. One of the nice things with traditional roguelikes is that usually you don't need to worry too much about the visual except for the bare minimum. I mean, we can add spells and status effects, and all we have to really think about is what text we're going to show the player in the log. But adding visual effects and animation, even if you wanted them to be just ASCII animation, would require some serious redesign, so you need to keep that in mind. If you're following the tutorial with me and you're thinking of eventually adding some sort of animation, you probably should start thinking about how this would work right now. You need to take a few things into consideration, like for example, how are you going to block the player's action while the animations are playing? How are you going to chain animation, like the casting, the effects, and then the explosion and the death animation one after the other? Also, an animation is a sequence of changing frames, so how are you going to handle this data? How are you going to know what your frame is made of and how to play them one after the other? And finally, consider that this will probably test the limit of handling everything in your game through a simple game states. And so, with this last scroll, we've added a health potion, a scroll of lightning, a scroll of fireball, and a scroll of confuse monster, but more than that, we now have a framework to build pretty much any items we want, and we've drastically improved our UI to show any kind of list we want. We can even do targeting with the mouse. So this concludes part 7 and 8 of the complete roguelike tutorial, and see you all next week for part 9 and 10. Bye!